Hi, this is Guy Burgess. I wanted to follow up on an earlier distinction that I drew between complicated and complex adaptive systems. As I said before, we're convinced that the key to moving beyond intractability and in fact dealing with an awful lot of the world's really difficult problems is to start thinking about those conflict problems as complex adaptive systems, not merely complicated systems. And that requires thinking in terms of systems. So I thought the good place to start with this would be to go back to an old article that Kenneth Boulding wrote called The Skeleton of Science. And this was one of his most popular articles ever, which for all of the things that he wrote is actually quite an accomplishment. But what he did, and this came out of the early days of general systems theory, is he outlined a hierarchy of systems, each becoming increasingly complex at each level. So he started out with a static framework system, and these are systems in which all of the parts exist in fixed and unchanging relationship to one another. The example he used to use was a chair, and it has, not the fancy kind of chairs that recline and all that, but just a simple chair that had legs and a back and all of that. The next level of system was a dynamic system in which one thing would cause another and another. And first of all, it can produce a nice causal chain. Some dynamic systems are what he called clockworks that go around, and all the components of the system exist in a changing relationship with one another. But those changes are thoroughly predictable. They're often repetitive. So the next level he introduced was a cybernetic system, where you introduce feedback loops. So you can have a negative feedback loop like a thermostat in a room, or if the room gets too hot, it turns off the heat, and that keeps things at a relatively stable level. And an awful lot of the systems in the universe really that keep society and keep the planet actually working and continually hospitable to life are these kind of cybernetic negative feedback systems. But there are also positive feedback systems, and you could understand that by simply rewiring a thermostat. And so when things get hot, instead of turning off the furnace, it actually turn the furnace on hotter. And if it got hotter still, then you turn the furnace up more and more. That's obviously an explosive situation. That's the mistake, believe it or not, that the engineers made in their design of the Chernobyl nuclear reactor, and that's why it was such a catastrophe, really. And there are all sorts of positive feedback, explosive loop systems. The next level, you start to get open throughput systems. He talked about things like rivers and flames, where you have a system that exists, but the flow of individuals or elements or material or matter through the system is ongoing. And you start to get here the most sort of primitive forms of life, where you have a cell, which is really an organization of atoms and molecules and there's a continuing throughput of food and waste products and that sort of thing. And it starts out pretty simple, and it gets more and more complicated. At the next level, he starts to introduce the biological world, the botanical world of plants and plant ecosystems, and not all that long after that, the world of zoological systems, where you have animals with the ability to sense their environment, make decisions, move around, and the ecosystems that surround that. At the next level, he actually adds two more levels. One, the sort of human psychology and the ability of humans to learn, and combine that with the ability of humans to organize themselves through language into very large-scale social structures. So you've got those systems. Now, overlay on this distinction that we had before between complicated and complex systems. So for the first three levels, statics, dynamics, and feedback systems, here you're really talking about complicated systems. This is the way the physical world works. And it's also the way in which mechanical systems designed by humans work. At the next level, you get throughput systems, botanical and zoological systems, where you've gotten into complexity. Here you're talking about the organic metaphors of the biological world and biological evolution. And then at the next level, when you pick up human systems and social systems, you add the additional level of societal evolution and societal complexity. Now, one of the problems that we run into is that if we're dealing with conflict, we're really dealing with conflicts at this third level, the human social level. But often the way we think is at the first level of static frameworks, dynamics, and simple feedback systems, mechanical systems. And the difference is enough that the truth is that the complicated models don't work as well as we would like on complex social systems. Now, it's also true that the nature of systems is cumulative. So even when you get to the level of human and social systems, there are a lot of the sort of basic general systems principles having to do especially with dynamics and feedback loops that apply at the social level. And what you're really talking about here is maybe not so much the nature of these systems, but the way in which we think about these systems. So to get a sense, we tend to think about conflict in static terms, static frameworks, all too often, where we just divide the world into good guys and bad guys. And once you've done that, everything is very, very simple. But it's not really very accurate, and it doesn't allow you to really navigate the complex social world in ways that allow the continued evolution and betterment of society. At the next level, you have dynamics, and here we had an earlier version of this diagram, and this is this notion that the social system consists of sort of opportunities for causal chain, and if you just had the right strategy, you could strike the billiard ball and everything would do just exactly what you want. And that has this assumption that in particular situations people will react in the same deterministic, predictable ways every time. And we have a lot of social structures that are organized in one way or another sort of around this framework. You certainly have the standard sort of military chain of command, which extends as well into non-military types of large-scale organizations. And you have the notion that the key to solving a lot of big problems is unity of effort, where you get in gigantic institutions and organizations of institutions, that is whole of government type responses, all to work out a predetermined plan, and everything works out as intended, assuming you've got your strategy right. And then we add another level to this sometimes, where we're actually starting to build in not just simple dynamics, but feedback loops, and that starts introducing another more sophisticated element of reality into our model. So we have simple little feedback loops like this cycle of violence, and they're more sophisticated versions of this. We also have a series of relatively simple models that explain the sort of stability of the power elite, the tendency of wealth to concentrate in the hands of the holders of capital, that sort of thing. There are lots of issues. Rob Rosigliano and a bunch of other folks working on complexity-related issues in conjunction with Peter Coleman and the Dynamical Systems Group and his Innovation Lab and all of that, have been developing much more sophisticated models of systems thinking, where you actually try to think through model, and they've developed some software from doing this with Kumu that gives you a sense of how all the feedback loops operate, where all the connections are, the overlay of feedback loops on top of feedback loops, and it's basically systems thinking. And that's vastly more sophisticated than a lot of the more simple framework static kinds of ways in which people have thought about conflict. So this sort of takes us up, at least in terms of the way we think about conflict, to the end of level 1. And one of the questions that we want to pose sort of in conjunction with this series of online seminars is there anything we can do to push the model still further, so we start to have some image of a new complexity-oriented, ecosystem-based paradigm that would be built on the foundation of all the earlier ideas, but would help us operate a little more effectively at this third level of systems, the gigantic, large-scale system. And one of the things that we might want is systems of systems thinkers. So if we can get individuals in these large-scale social systems, certainly individuals in prominent roles, to start thinking in more systemic terms, we're likely to be a lot better off. And more broadly, what we need really is kind of a way of supplementing what all the other paradigms that are out there, so with something that I call an ecosystem-oriented paradigm that's focused on finding ways of encouraging very large numbers of independent actors to pursue their own self-interest by approaching conflict in more enlightened ways, or simply getting a lot more people working on the conflict problem. So this is what we're going to focus on as we get through this series of seminars, and hopefully we'll start to put together a discussion and some ideas on how we can really do that. And for now, the question that I'd like to pose: are you aware of successful, or maybe not successful, but instructive efforts to promote the more active involvement of a much wider array of citizens in efforts to promote more constructive approaches to conflict?